So that really means that my rate is 4 chirps per degree Fahrenheit. Or in other words, my rate is 4. And earlier we had talked a lot about this. How do we do our U sub whatever? And I told you you could start with any number you wanted to. Remember, we've been doing U0, U1, that kind of thing. So I'm going to do something completely different this time. I'm going to say that my starting position is not going to be U0. It's not even going to be U1. It's going to be U50. Because it's the first temperature I see for the x values. And that number is 40. So my beginning value at temperature 50 is 40 chirps. And then subsequently, my UN is equal to UN minus 1. And how many chirps am I going up by each degree? Each degree? 4. So I just go plus 4 on the end. And what would happen is, for you guys, if you went to your calculator and you typed this in your recursive equation, and you went into your table and you started looking at start at 1, go up by 1, you would see the different, you would not see this table. Because you would have something like 1, 2, 3, 4, 50, 51, 52, 53, 54, 55. Or you could actually set your calculator to do that. So what I could have done is, if I'm in my calculator now, you don't have to pull out yours, don't worry. And I start at 50, and I know that I'm, oh no. So I'm adding 4 for each chirp, and I'm starting at 40, right? That was the number of chirps. I could go into my table set. Instead of going up by 1, if I didn't want to do that, I could start at 50 and go up by 5s. So now if I look at my table, if I do that, I will see the table that they gave me if I want to see the table that they gave me. Or what I could have done if I wanted to is I could have, if I was curious about a different one, I could have just gone up by 1 degree and then look at my table to see what's going on. And I would have seen something a little bit different because I'm going up by 4 chirps every degree. And then I could look at the 50, the 55 was 60, so on and so forth. So you can change your table to make that happen. But what I wanted to show you is, in the past we've talked about the fact that you did not have to start at 0, you do not have to start at 1, you can start wherever you want. Okay, so that just so you know. Questions about that? Okay, let's go to the previous one then, which is number 2. The long run value yesterday we talked about was the restock value divided by the percent lost. So in this particular case, the restock value is, I'm adding on 50, so you take 50, and I'm taking away 34% each time, so I divide by 0.34, and whatever number that turns out to be, thank you, 147.06. This is your long range value, or the limit that we talked about yesterday. Questions about number 3 or number 2? Number 2 is exactly what we were doing yesterday. Number 3 is understanding that sometimes the tables they give you are not inconvenient. And you'll have to interpret some stuff from them. Yeah, interpret some things. That was funny for anybody with a sense of humor. Number one is very different. Number one is talking about a sequence of things, and the sequence is really strange. If you look at how much things are going up by each time, they vary a lot. So, for us, what we want to be able to do is we want to be able to figure out what's going on. And the way to do that is to look at how much things change. So, what I want you to notice is that when you see something where they're not going up by the same amount each time in a table, one of the things that you can do, if you know it's not linear, like if you were to put this in your calculator and graph it, what you would see is that these change by different amounts. Look at this. 1950 to 1960, that's a 10-year jump. 1960 to 70, 10, 10, 10. And then it goes to 96, that's only a 6-year jump. And then it goes to 2000, that's a 4-year jump. If the jumps are changing, to find the rate is not an easy thing. So what I want to tell you is, if we look at the beginning, and we look at the end, what I notice between those two things is that my rate changes quite a bit. So, what I'd like you to try and figure out is to go from 7.6 to 27. Take 2 minutes, see if you can figure out what the rate is. So one of the things that's kind of weird about this is you might not realize this, but if you look at the very first number, that's 7.6. Oopsie. And then you start looking at how many blanks are in here. And then the last number, 27. In between all of those things, total, how many numbers are there? To go from 7.6 to 27, how many numbers did I go up by? 50. From 1950 to 2000, there were 50 jumps in between. That's kind of weird. And the table only gives us a snapshot. So one of the ways to find out your rate is to understand that when you don't have something that's linear, like going up by 3 or 5 or 10 or something like that every single time, 1.5, that you're actually multiplying by something. And we don't know what that something is. So if I just called it the rate R, I would multiply R by itself 50 times. 50 times. So I take 7.6 times something, call it R, that gives me this one. Take that number times R, get this one. Take that number times R, get the next one. So what we're saying is that there is a number, 7.6. Then when you multiply it by something, I don't know what that thing is, so we call it the rate, R, 50 times, you will get out 27, way over here on the end. So to find this thing, you would have to divide both sides by 7.6, which means that you have R to the 50th equals 27 divided by 7.6. Or in other words, it equals, and I don't know, some crazy decimal, I get 1.027 roughly. But that's 50, 50 of the R's together. And you don't want that. You want to know just what the rate is. So the way, if we had R squared, how would you want to do R squared? Square root it. So we're going to undo the 50th, and the way that we're going to undo it is we're going to 50th root it. So I'm going to take the 50th root of that, and I'm also going to take, I think this number is actually wrong.
3.55.
3.55?
Yeah.
Thank you. I'm going to take the 50th root of 3.55. I think I was coming up with the answer right away. So the 50th root and the 50th power cancel each other out, and I get r. And the thing that's kind of crazy is to do this 50th root on your calculator, you have to do this. 3.55 caret 1 fraction 50, or divided by 50, parentheses, enter. And that's how I got the 1.027 roughly. This is one way to get your rate. Why do you want this rate? Because you're trying to find out how to write the equation. So if you're writing the equation now after you've found your rate, to write my equation, I know that my u, what should we call it, 1950? U0, U what?
U0.
Okay, U0 is 7.6. That's my beginning value. And my UN will be the UN minus 1 times 1.027. That means every year I go up, I'm going up by 1.027 million people. And the biggest, most difficult thing to find in this problem is, what is my rate, so I know what to multiply by. So one way is to do it the way that I've done it. That's the algebraic way to do it. What I want to also show you is there's a way on your calculator that you could do this. And I'll put the screen back up in a moment. So on your calculator, one of the most powerful tools on these graphing calculators are your lists. If you go to your list, and don't do this right now, but if you go to your lists and you put the first thing in list 1, the second thing in list 2, after you've done that, you can go to stat, which is right here, which stands for statistics. You can go to where it says calculate, and if you scroll down to the one that says EXP, which stands for exponential, which on mine is number 0, and hit return, it'll say do an exponential regression. And if you hit enter, you will see that the B is the rate that you're looking for. And notice that this calculator calculates it as 1.026. So we're only 1/1000th off the other way. So there are two ways to do it. One way, the way I showed you algebraically, or the second way, put it in your list and use exponential regression. Yes, sir?
Which way do you want to use it? I want to see what this is.
I personally don't care which way you use it. If you're using your calculator, show me the steps that you did. Like write them out on your test so I know which one you did. Because in the end, what's going to end up happening, I think the question that would end up on the exam is, here's my table, write my recursive equation. And so in the gray is the recursive equation that I'm looking for. And I try to teach you what I think are the best tools to be able to do that. So I always try to show one algebraic way. And then if I think that there's a calculator way that's more efficient, I also will show you that. Because in my opinion, that's why we have these great tools.